Section 9.3 Hypothesis testing for the population mean when population standard deviation is unknown. Up to this point in the chapter, we assume that sigma or the population standard deviation was known. However, in most hypothesis testing applications, this is not the case. If we knew the population standard deviation, we most likely will also know the population mean, which is the purpose of this hypothesis test. Therefore, we substitute the sample standard deviation, or S, in place of sigma. The sample standard deviation will always be available to us once we have collected the sample. When doing so, we use the student t distribution for the test statistic rather than the normal distribution. When we use the t distribution, we need to assume that the population of interest follows the normal distribution. As your sample size gets better, and the shape of the population is not very skewed to one side, the shape of the t distribution becomes similar to the normal distribution as the sample size increases. An example of one-tailed hypothesis test for the population mean when sigma or the population standard deviation is unknown. Suppose the self-serve checkout pile system was used to test the feasibility of installing future system at other store location. Currently, the average total time to check out with a cashier is 5 minutes. The store has decided that if the average checkout time in the pile system is less than 5 minutes, additional self-serve system should be installed to ease the burden of human cashier. To test this premise, we check out time of 12 randomly selected self-serve shoppers were recorded. The time are shown in table 9.6. To perform this hypothesis test, we will follow 6 steps. Step 1. Identify the null and alternative hypothesis. Null hypothesis, mu greater than or equal to 5 minutes. This is the status quo. Alternative hypothesis, mu less than 5 minutes. Step 2. Set a value for the significant level alpha. For this procedure, the level of significance still represents the probability of making a type 1 error, where we reject the null hypothesis, but it is actually true. For this example, we set alpha equal to 5%. Step 3. Determine the appropriate critical value. Table 9.7 shows an excerpt of Table 5 in Appendix A, which lists the t-score values. To find our critical t-score, we locate the column associated with alpha equal to 5% for a one-tailed test, and the row that correspond to n-1 degrees of freedom, where n equal to the sample size. Because we have 12 customers, we have 11 degrees of freedom for this example. The t-score for alpha equal to 5% with 11 degrees of freedom is 1.796. Step 4. Calculate the appropriate test statistic. The test statistic is shown in equation 9.2. Tx bar equal to x bar minus u mu of null hypothesis divided by s divided by square root of n, where Tx bar is the t-test statistic for the sample mean. X bar is the sample mean. Mu of null hypothesis is the mean for the sampling distribution, which is assumed to be true for the null hypothesis. S is the standard deviation of the sample. N is the sample size. In this example, x bar equal to 4.2. 4.2 minutes and standard deviation of the sample mean equal to 1.42 minutes. Therefore, the t-test statistic is equal to 4.2 minus 5 divided by 1.2 divided by square root of 12 equal to minus 1.95. Step 5. Compare the t-statistic or tx bar with critical t-score, the t-alpha. The t-test statistic is equal to minus 1.95 and t-alpha is equal to minus 1.796. We come to the reject-Hasnell conclusion. Figure 9.12 illustrates this finding. Step 6. State your conclusion. Rejecting the null hypothesis indicates that we have support for the alternative hypothesis, H1, which is mu less than 5 minutes. We can conclude that the average self-serve checkout time in the pilot system is less than 5 minutes. Estimating the p-value using students' t-distribution. Recall that the t-statistic is equal to 1.95. We need to find the critical t-score that bracket tx bar equal to minus 1.95 or plus 1.95, along with n minus 1 equal to 12 minus 1 equal to 11 row in table 5 from Appendix A. Table 9.8 shows that this value lies between 1.796 and 2.201. To find the corresponding p-value, we go to one tail row and find between 2.5% and 5%. Even though we do not have a precise p-value, using alpha equal to 5%, we can still reject the null hypothesis. An example of a two-tailed hypothesis test for the population mean when sigma or the population standard deviation is unknown. The two-tailed hypothesis test with an unknown sigma follows the same 6 steps as in the previous one-tailed example. To demonstrate, let us test a claim that average American watch 34.5 hours of television per week. The number of hours of television that 10 people watch during a week was recorded. The results are shown in Table 9.9. We will perform this hypothesis using the following 6 steps. Step 1. Identify the null and alternative hypothesis. Null hypothesis is U equal to 34.5 hours. This is the status quo. Alternative hypothesis, mu not equal to 3.4 hours. Step 2. Set a value for the significant level alpha. We will use alpha equal to 2%. Step 3. Determine the appropriate critical value. On table 9.8 locates the column associated with alpha equal to 2% for a two-tailed test, and the row that correspond to n minus 1. The n or sample size is 10, so n minus 1 equal to 10 minus 1 equal to 9 degrees of freedom. Table 9.8 indicates that T alpha divided by 2 is equal to 2.821. Step 4. Calculate the appropriate test statistic. From data in Table 9.9, we can use equation 9.3 to find out this test statistic. X bar is equal to 34.5 hours, and S, sample standard deviation, equal to 16.4 hours. So T x bar is equal to x bar minus mu of null hypothesis divided by S divided by square root of n, equal to 39.6 minus 34.5 divided by 16.4 divided by square root of 10, equal to 0.98. Step 5. Compare the t-statistic or Tx bar with critical t-score or T-alpha. Since the absolute value of Tx bar is equal to 0.96 and T-alpha divided by 2 is equal to 2.821, which means because 0.98 is less than 2.821, we do not reject null hypothesis. Table 9.13 illustrates this finding. Step 6. State your conclusion. Failing to reject hypothesis indicate that we do not have support for the alternative hypothesis, which is mu is not equal to 34.5 hours. However, we cannot conclude that the average number of hours equal to 34.5 hours because that would accepting the null hypothesis. We can only say that we have no evidence to conclude that the average does not equal to 34.5 hours.